Hi everyone, this is Karthika, Faculty of Physics, working in SNS College of Technology. So in this session, myself going to explain about the few topics in photonics, that is called a laser. So here we can see what is photonics and what is acronym for laser, invention of laser, principle of laser, and then population inversion, pumping method, characteristics of laser, and then what would be the difference between ordinary and laser light source. So photonics is the science and technology of generating, controlling and detecting photons, which are particle of light. We know that light has a dual nature. One act as a wave, another one act as a particle. And then laser is a device that generates light by process called stimulated emission. Acronym for laser is light amplification by stimulated emission of radiation. And then the invention of laser is nothing but T.H. Meiman in 1960. First solid laser called ruby laser. So this is the first laser we can see in the picture. This is nothing but a ruby laser. And then the principle of laser is nothing but stimulated emission. Here the incident photon triggers the excited atom to make transition to the ground state E1, and this transition generates a second photon which is identical to the triggering photon with respect to the frequency, phase and propagation direction. So this picture shows when the atom is exposed to light that we have three process, that is absorption, spontaneous emission and then the stimulated emission. So the absorption is nothing but the incident photon in the atoms present in the ground state absorbs some energy from the incident photon and moves to the excited state. This is called the absorption. And then spontaneous emission without getting any external energy, it can be transmitted from excited state to ground state by emitting the photon. And in stimulated emission, with the help of incident photon that can be emitted as a two photon, that is multiplication of photons will be have. So in stimulated process, we have the multiplication of photons through stimulated emission leads to coherent, powerful, monochromatic, collimated beam of light. This light is known as laser light. Next one is the population inversion. So in population inversion, the number of atoms in the excited state is greater than the number of atoms in the lower state, and this is very important for achieving the stimulated emission. So this picture shows the normal population and then the inverted population. So in normal population, number of atoms in the ground state is more than the excited state, and in inverted population, the number of atoms in the ground state is less than the excited state. Next one is the pumping methods, and this is useful to achieve the population inversion. So here we have a different types, that is optical pumping is there, electrical discharge method is there, direct conversion is there, inelastic collision between atoms is there, and then the chemical process is there. And we can see the optical pumping. This is nothing but by using the light energy we can induce the atoms from ground state to the excited state. So this is called optical pumping. Here we can use xenon flash lamp and krypton flash lamp. um, Second one is electrical discharge method. Here the electron can collide with the atom by applying the electric field, and then the atom moves to the excited state, and this is useful for carbon dioxide laser. Direct conversion, the electrical energy here can be converted into light energy. So this method is used in semiconductor laser. So next one is the inelastic atom-atom collision. So here we have the two atoms which have the same energy level, and in that one of the atom is collide with the electron and absorb some energy and then moves to the excited state, and the excited atom that collide with the B atom, and that can be moved to the excited state. So the example is helium neon laser, chemical laser. So due to some chemical reactions, the atoms may be raised to excited state, dye lasers. So next we can see the characteristics of laser. It have a high directionality, high intensity, monochromaticity, and then high coherence. So high directionality means it can travel for a long distance because of a high intensity, and it can be concentrated on a small area, so it have a more brightness. And then monochromaticity is nothing but laser contains only one frequency and that have a very little spreading. And then coherence, so it have all the properties will be the same here. So the photons will have a same process, and these properties are the difference between the ordinary light source and the laser light source. And then the essential components for a laser system is nothing but active medium, pumping mechanism, and the optical resonator. So optical resonator is nothing but here we can have a reflecting surface or two parallel mirror placed around the medium, and the light is reflected by the mirrors back into the medium and is amplified. Thank you.